get started. Okay, can everyone see my screen and hear me?
We see you and we hear you.
Excellent. So thanks for giving us some time to talk about our platforms today. So we're going to touch on several of the 7 Bridges platforms. Today we're mainly going to focus on the Cancer Genomics Cloud because it's what we're going to be using for our demo tomorrow. But we're going to highlight throughout the different aspects of the platforms, of the other platforms as we go through. So to orient us, what we're going to go through today is the basic overview of how our platforms work. Again, highlighting the differences for the non-CGC platforms. We'll go through the organization of how things work on the platform, focusing on projects. Then we'll touch on how data can be added to projects and on workflows. And then we'll go into a bit of the back end after we go through sort of the front end piece here as well. So one of the things that's different about the 7 Bridges platforms is that it's a little bit more like the Gen 3 discussion than the Bro discussion that we've already had today, where we actually do have 3 different installations of the platform. And that grew out of policy differences, user community difference, a kind of a user-driven way that this ended up having 3 different installations of the platform. So I'll give a little bit of background on each of the platforms now. The 7 Bridges Cancer Genomics Cloud was our first academic platform. This is funded by the NCPI, and it's one of the cloud resources within the larger Cancer Research Data Commons, which Bill went through briefly this morning. So the model of the CRDC is that there's many different nodes, many different places that the tools and so on can come from. And the cloud resources are basically the engine of how analysis happens within the CRDC. So as Bill mentioned, it started off a little bit differently, but now it's shifted to this kind of more distributed model where there's many, many different nodes, 3 cloud resources, of which we are one. And that's where users are expected to sort of come in and actually run their analyses. Sort of basic features of the CGC and our other platforms is we attempt to co-localize 3 things, similarly to the other platforms that we'll hear from today. Basically, we're co-localizing access to data, the tools and workflows you would need to analyze that data, and the computational resources you would need to analyze that data. So data itself, tools, and computation to do this all in the cloud in a secure and scalable way. One of the really nice things about the 7 Bridges platforms is that we have a very user-friendly user interface where you can access all of these data sets and you can start workflows in a very UI-driven way. And everything can also be done via an API as well. And everything on our platform was built with very fair principles in mind. So, you know, aiming for reproducibility, interoperability, and so on. A little bit of history that Bill also touched on. We've been around since approximately 2014, officially launched in approximately the beginning of 2016. What this really shows here is that initially we went from a model where the cloud resources were actually hosting the data, starting with TCGA, and have more recently moved to a model where other nodes within the Cancer Research Data Commons are actually hosting the data itself, and through links it can be accessed through the cloud resources, including the CGC. So currently we have over 5,000 different users on the CGC, and we have integrated with the Genomic Data Commons, the Proteomics Data Commons. We recently integrated with the Canine Data Commons, and we're about to integrate with both the Clinical Trials Data Commons as well as the Cancer Data Service. So moving in this direction of interoperability between all these different nodes and the cloud resources. A little bit of background on our other platforms. As I mentioned, they're separate installations, but basically have the same set of features and same, you know, we have the same FAIR principles, same co-localization of data tools and resources on all 3. Kvatica is another one of our very early platforms. The focus of Kvatica is on pediatric cancer, which Alison Heath gave a nice overview of this morning. And what the Kids First Kids First Data Resource Center is a portal that can lead into Kvatica as well. So that's another one of the nuances of Kvatica versus the others. So it's a way to make the Kids First data analyzable, basically, and it also has the harmonized workflows for that data. We also have the Sunbridge's version of the Biodata Catalyst, the NHLBI platform. And the focus of this platform is making the top med data accessible. And the tool focus here is actually on GWAS analysis. So there's many, many top med studies. It's a really rich data set. There's a lot of different types of data in there. And we've heard about some of the different tools you can use to search through that data today. And tomorrow we'll hear a little bit more about some of the aspects you can do to analyze it. So we have a couple different specific tools for doing GWAS on the Biodata Catalyst platform. I should mention that all three platforms can be used on both AWS and on Google. So a little bit of the basics in getting up and running on the platforms. So it's really easy to make an account on the CGC, and it would be a good time now to remind you that if you want to participate in the demo tomorrow, you can sign up now with your email or with your ERA Commons. And this login screen that I'm showing on the right here is basically identical for all three platforms. So you can use the same ERA login to get access to all three of those. On the CGC, we have all users get started with about $300 of pilot funding, and we found this to be a really, really useful thing for users. The cost of cloud computing can be a little bit scary, mostly due to kind of fear of the unknown. And having a small amount of pilot funding gives users a way to get in there, start accessing the data, understand how everything works in the cloud without having to figure out billing right away. All of the platforms also have a very rich set of tutorials and data to get users up and running on the platform. And everything is backed by a large team of technical support staff, as well as bioinformaticians and engineers. One of the nuances of Kvatica is that users can also enter Kvatica through the Kids First Data Resource Center, which is a portal to access the data associated with the Kids First project. And you can see on the right here, there's a button for you to connect to Kvatica. And when you connect to Kvatica, you go through that same login screen that I showed a minute ago. And as I'm sure Allison will talk about tomorrow, one of the other nuances is Kvatica is there's a bit more logging in than with some of the other flows. Once you've logged into the platform, the first step for any project is basically create what we call a project, which is the major organizing principle of how things work on the platform. These are synonymous with workspaces or sandboxes or some of the other terms that are used for sort of the place where you keep everything associated with your analysis. So the project owner can control everything about that project, who can be added, what permissions each person can add, who can see what data, and so on. And then all the pieces you would need for that analysis are held within the project as well. So all of the files you would be analyzing, all of the apps and tools you would be using to do that analysis, and then all the information about the actual task itself. So when you run the actual analytic workflow, that data is all in the project as well. And the results of that workflow also stay in the project. So project is kind of like the core organizing principle for how everything is connected together within the platform. One of the nuances of the Biodata Catalyst platform is that for studies other than TopMed, people basically have permission to the whole study or they don't. So you get access to the entirety of TCGA or you don't have any access to TCGA. The TopMed studies are a little bit different where there are consent groups based on what patients consented to, and there can be multiple of these consent groups per study. So for example, if you had access to the Jackson Heart study, you might not have access to all of the data. So there's more than one different consent group in here. You can see them here, HMBR, IRB, and DSFDO, IRB, and certain people may have access to one, the other, or both. So permissions work a little bit differently on Biodata Catalyst in that we have consent level permissions rather than sort of data set level permissions. And we get all of this information from dbGaP through Fence. So once you've come in and created a project, you can access a whole bunch of different public data sets from the different platforms. So the different platforms allow you access to different data sets, and this is really driven by research area. So a user who is interested in cancer would typically go to the Cancer Genomics Cloud. A user that's doing, let's say, blood research would go to the NHLBI platform. So the kind of top and right area of this big area of the data sets you can get to from the CGC. The bottom left corner are the additional data sets you can get to through Kavatica if you have the right authorization, of course. And then on the Biodata Catalyst platform, you can have access to TopMed. And again, really, this is all driven by the user interest. Several of these data sets can be explored through our query tool called Data Browser. So Data Browser is a graph-based query tool. This is a little bit different from some of the other tools that we've heard about today. And one of the advantages of doing a graph-based query with a large graph-based database on the back end is that you can do kind of not just linear queries, you can do these types of branched queries. Where this really becomes important is that when you want to do something that's maybe biologically very intuitive, such as matching tumor normal pairs, but computationally very challenging, these branch type structures can be very helpful for doing this much more easily. And we've had several users while working on interoperability projects kind of run into issues trying to match these things up. Data Browser makes this really easy. And basically any aspect of the metadata that we have on the platform, you can kind of filter down to different groups on in that way, and then easily copy all of this data into your project. So it's a very popular way that our users come in to build cohorts on our platform. And you'll get a lot more information about this tomorrow when we go through the demo, as well as in the backend section that's coming up next. Another nuance is that you can also build cohorts and come in through Kavatica through the Kids First Data Resource Center. So this is another way of doing faceted queries for the pediatric data that's present in the Kids First Data Resource Center. Similarly, you can build a cohort this way and kind of send it off to Kavatica for analysis. If you have your own data, we have a whole bunch of different tools, which will be a big focus of the next section to bring data into the platform. Command line uploaders, desktop-based uploaders, and so on. So there's a lot of different ways for users to bring their own data in and analyze it by themselves or analyze it alongside the public data sets. So usually what people want to do once they have all this data is actually run a workflow. We have a couple different ways to bring in workflows. We have integrated with Dockstore, as mentioned in the Dockstore discussion, so you can get everything in CWL that's in Dockstore imported into the CGC. And we also have a very large and rich public apps gallery. So we have almost 500 now tools and workflows that have already been optimized for use in the cloud. So everything in the public apps gallery has been tested by our bioinformatics team. It should work, it should be optimized, and it will often also contain information about how to run the tool and how much you can expect it to cost and so on. The public apps gallery can be narrowed down by what you're looking for. So you can see here, there's a whole bunch of different categories of tools that you can look through, and basically whatever your genomics research need is, we probably have tools for it in the gallery. Once you have your tools ready, you can, a good example of how the platforms can be so useful for interoperability is seen in Kids First, where we have several of the Kids First Data Resource Center harmonized workflows that are available through the public apps gallery on Kavatica. So anybody doing this type of pediatric data can ensure that they're using the same workflow as their friend is using or their collaborator is using without having to worry about reproducibility, portability, all of that. If you want to bring in your own tools, so you can take tools from the public apps gallery, you can bring in tools from Dockstore, you can also create your own tools and bring in your own tools. And we do that through a combination of Docker and Common Workflow Language, which I think were described very excellently in the Dockstore discussion. So Docker is used for making sure the environment is packaged. Common Workflow Language is used to make sure the the tool can run correctly in that environment. And we have a really nice feature on the platform called Graphics Composer, which is shown in the animation here, that gives you a graphical interface to wrap tools or create tools wrapped in CWL without having to be a CWL expert, basically. So you can use a graphical interface to put together the tools, connect multiple tools together into a workflow, basically have a lot of flexibility over what type of bioinformatic analysis you want to do in a very easy to use, community oriented way. And we'll go through this in more detail when we do the demo tomorrow. So we'll actually make a workflow using Ravix web editor. So just to give a little highlight about the steps that a user would go through as a preview also to tomorrow, let's say you wanted to do a gene expression workflow, you could find a gene expression app in the public apps gallery. If it needed a little bit of modification, you needed to step upstream or downstream of that, you can put that together with our web editor. So you can find the tools you need and connect them together in a really easy drag and drop type interface, which is, you don't have to figure out all the inputs and outputs and command line yourself. You can do it via this nice graphical interface. And then you can actually run your tasks. So when running tasks, we have a bunch of different features. We have this nice feature where you can batch tasks. So when you scale up and you might be running thousands of files, you may want to batch those files so that they run in different groups to sort of organize your data better. And any aspect of the metadata that we have available, you can batch on. So you can batch by tumor versus normal, you could batch by sample ID, you can batch by all sorts of different categories. And we found that this is a really nice feature for our users. It's very popular to be able to organize their data and organize their analysis this way. You can also set all the parameters for the workflow from this page, and then the outputs will show up here as well. Once you've run a workflow, you can continue on to do more interactive analyses with the integrations we have with RStudio and with Jupyter notebooks. So you can basically spin up an instance of R or Jupyter in the cloud. So all of the files from your project, all of the outputs and everything, all stay in the cloud in one place. You don't have to download them and then run them locally. You can keep everything in the cloud. We have a number of different computational resources to choose from when running these types of workflows. And you can use it exactly like you would use it locally. So this is also a really nice feature to go from an analysis like, let's say, gene expression to something more like making PCA plots and so on. So here's kind of an example of how you would use, well, we call this feature Data Cruncher, the ability to get to these notebooks. And here's an example of what it looks like. You can see it looks exactly like, in this case, the RStudio environment. And then you can use it to do interesting visualizations once you get to this point, such as, for example, violin plots that can compare gene expression values between data. So you can get to sort of the figure component of your bioinformatic analysis, all while staying within the cloud, which is really nice. Another nice feature about the notebooks that we've explored more recently is how they can enable interoperability. So for integration, for example, with the proteomics data commons, this is mainly done through the platform. But if a user, for example, wants to get additional metadata from the proteomics data commons, they can call the API for that, for the PDC, basically from a notebook from the CGC. So you can call APIs of other nodes, other places you might be working with through our notebook feature here. So that is the front end, and I can probably best to keep going and move on to the backend component now. Okay, so initially the backend component was supposed to be done by one of our bioinformatics engineers, Anna. She unfortunately got a very bad flu, so I'm going to give the talk to save her voice, but she's on the call and can handle any questions. She might be on the chat right now. but I just want to make sure Anna did basically everything for this section, and I'm just the mouthpiece for this section. So now I will get into some of the more details of the back end of the platform, going into a little bit more detail about what underlies all of the pieces that I talked about in the first section. So today, in this section, we're gonna, when thinking about interoperability and what that means on our platforms, we realize that that really comes down to accessing data. So, data is located in all different places, and there are many different ways to access it, and running workflows. Those are kind of the two big aspects of interoperability. So we'll go over the architecture of the platform, and then we'll also go through a couple of different vignettes about how you can get data into your project, basically. And through those, we'll touch on the backend services, how metadata fits in, and how authorization fits in as well. So to move into the platform architecture, this is a simplified diagram about how, giving in kind of an overview of how things work. The way these 7 Bridges platforms are structured is that we have an extensive middleware layer on top of the cloud, so AWS or now Google as well. And this middleware layer is a series of microservices. So no matter where you are, where you came in from, what's going on underneath, kind of the look and feel to the user is the same. So for example, we have a microservice for running tasks. No matter which platform a user is on or which environment they're in, how they run that task will essentially feel the same to them every time. Another example is in billing. We have a billing service in this middleware layer. So while we entirely pass through the billing costs from AWS, the actual billing itself is managed through the platform. So the user's interacting with us when they do the billing, if they want to use different billing groups, use different credit cards, and so on. So we handle the billing with completely passing through the charges from AWS. One of the most important features of the middleware layer is what we call our file system, or what we call Vapor Store. So you may hear me refer to both the file system and Vapor Store as we go through this. And what that basically is, it's how we deal with files and metadata and everything associated with them on the platform. And what the Vapor Store, the file system layer, allows us to do is basically interpret tools as if they're running locally through the use of index files. So this has a lot of different implications for how things work on the platform. For example, bundles aren't really so much of an issue for us because of how we deal with the index files. Everything associated with metadata is also handled through the file system. So by having all the metadata information available in the file system, it enables us to do things like search very quickly, or being able to batch, like I discussed a few minutes ago, very quickly. And this is basically sort of a more streamlined user experience. And conversely, having this file system, it can result in a little bit more effort for us. We have to maintain the file system and all the different services. And it does also mean that we have to spend a bit more time indexing, because having that information there to be more performant means we have to put it in there in the first place. So we will be referencing the file system kind of throughout this talk and how it informs how things work on the platform. So as I mentioned, we're going to go through a couple different ways that you can bring data into the platform. I touched on them in the previous section. And then here in this animation, we're kind of scrolling through all the different ways you can bring in data. We have a data browser, which we talked about a little bit. We also have a thing called public projects, where you can access whole data sets in basically anyone in the public can get to them. And today we're going to focus on 2 of them, or 3 of the many ways we have to bring in data to the platform that are kind of specific to 7 Bridges and offer a sort of specific set of advantages to users. So the examples we're going to go through today are volumes, HTTP, FTP, and public data sets. And in each example, we'll also highlight a piece of the backend that's important to making that process work. So the first method we're going to talk about is something called volumes. And this is a way for users to connect to the 7 Bridges platform without moving their data. This is a feature we first developed through Kvatica, where we were trying to bring consortium data that's located in a consortium bucket into be analyzed on the platform. So if a user has a bucket that has, institutional boundaries around it, around security, billing, or other conditions, the user can sort of maintain all of those boundaries while still taking advantage of all of the capabilities of the platform through this volumes feature. How this actually works is that the platform itself has buckets and computational instances associated with it, and a user may have their own buckets that they have their own resources associated with that. And what the volumes feature does is basically securely connect them together through IAM, and it allows the files present in that bucket to be accessed from the platform for running workflows. So the data stays in the bucket itself. The data doesn't move. The only time the data does actually move is when you spin up a computational instance, and then the data is streamed into the platform during the running of that instance, and then is no longer there once the instance is over. You can do this either read-only or read-write, and once the workflow is finished running, all the data can also be stored in the client's bucket as well. So the volumes feature has been really useful for a lot of our collaborations and a lot of these sort of consortium type concepts where there's other management associated with a bucket, and connecting it to the platform is much easier if the bucket kind of stays where it is and the data stays where it is. When you connect a file to the platform via the volumes feature, we basically create an alias on our system. And an alias is just a pointer that points to the bucket location of that file. And you can see here in this list of files, the aliases with the little bucket next to it are from a volume, whereas the aliases without that are on the platform. The aliases are full entities on the platform, so you can add metadata, add tags, use them to organize in that way. And one thing to point out when using the volumes feature is that if anything in the bucket changes, the link behind the alias won't work anymore. So it's just something for the user to be aware of. What this is actually happening on the back end is represented in a really simplified fashion here. So what we're showing here is the simplified version of what the vapor store, the file system, would look like. Basically a simplified series of directories and files. So as I mentioned, projects are the kind of the organizing principle. And then for each file, there's a series of information that's held within the vapor store. The important pieces for this example are the vapor store ID, which is the 7 Bridges unique identifier for that file. And in the case of the CGC and Kvatica, this is actually the DIRS ID. And then the store provider, which is essentially the location of that file. So the link to where that file would be in the user's bucket. There's a whole bunch of other information, including metadata, that we'll get to in subsequent sections as well. So that is volumes. Now I'll get into HTTP FTP as a data import method. So this is a way that you can move data between platforms, either 7 Bridges platforms or other, basically anywhere you can get a signed URL or an FTP link. So it's a very easy way to move data around in that fashion. So I'm going to show a quick demo of how you would move a file between Biodata Catalyst and CGC using this method. So here you can see this is the Biodata Catalyst platform. You can essentially generate a download link, which you can use to download, or you can copy it to another platform like the CGC. So if you go to the FTP section, you get a box where you can paste in that link, add tags for organizational purposes, and it will actually copy that file into the second platform. And this will work not just for moving between platforms, but this will work for any signed URL or FTP link. And this makes it really easy to kind of move data between platforms. What's happening on the back end here, here's again our simplified representation of the file system. We have 2 platforms and 2 installations, so we kind of have 2 different versions of the file system. And that means they have 2 different vapor store IDs in this case. And the file is actually, in this type of example, the file is physically copied from one instance to another. One thing to point out here, so again, they'll have two different vapor store IDs because the file is actually copied, and then the location will refer to the specific location in each of the two platforms. One thing to just point out here as well, once the user has the download link, they're essentially taking on responsibility for that data. So the onus is kind of on the user to keep track of where that data is. One thing to notice here is that you can see there the metadata is also stored within the file system. And when you transfer the file, the metadata is not transferred with it. So that gets into how we handle metadata on the 7 British platforms, which is a very important topic. We have a whole bunch of different ways to add metadata into the platform and areas in which you can add metadata. There are a bunch of different predefined fields to make it easy for users to organize and add context to their data. And there's also a series of custom fields where users can define their own fields for the specific data they're working with. So for example, if they were working with proteomics data, most of our predefined fields are focused on genomics data. They have the flexibility to add fields as needed. So what we're showing in this little animation is how you would add metadata manually for, say, a single file. And if you were adding many files or had a lot of metadata, you can also do this by uploading a CSV full of the metadata. And we use this metadata in a lot of different ways, and it's stored within the Vapor Store, as we saw in the previous slide. The metadata is used in the data browser, for example, for search. It's used for adding context so that the user can see, you know, what sample was this again? Where did I get this data from again? And importantly, it's also used for running workflows. And this becomes really important when you're running scalable workflows, where you might be running, again, thousands of files. You might want the ability to organize them into different batches. So here's some example of fields that we consider essential for running a workflow. So sample ID is a key piece of information about what that file is and is often used for batching. If you're running anything using paired end data, it's important to know which pairs go together. So that's critical information that's stored within the metadata. If you're doing anything with an alignment, you have to know what genome you're aligning it to. And experimental strategy can help the user understand the context of that data in terms of what that data is and what tools are appropriate to use with it. And here again is an example of a task page that can show how you would run a workflow, say, at scale. We have this batching feature where you can group files together when you run large analyses. In this case, we can batch by sample ID, but you can really batch on any of the metadata fields present here. And here we're showing, like with FASTQ data, you may want to understand how to pair those ends together. That information is held within the metadata. And all of this propagates into the outputs as well, which is present on the same screen. And to be able to take advantage of all of these features I'm describing for both search and for running workflows in a way that's performant, so it's quick enough, we basically have to have all this information in the platform already. So this is why we do a lot of the pre-indexing that we may have brought up a couple times. So basically adding all of this information into the Vapor Store is what allows us to do this right away. So now we're going to talk a bit about data sets, which will lead nicely into the demo tomorrow, which is going to focus on TCGA data. And through this part, we'll talk a bit about how authorization and authentication work on the platform. So TCGA data is one of the most commonly used data sets on the CGC, and it can be searched and accessed and cohorts built through the data browser, which again is this graph-based query tool, which enables you to do really complex analyses. It also enables you to do branched analyses, which can let you do things like matching pairs really easily. With the data browser, again, this is where that sort of pre-indexing step comes in. We have all this metadata present in the Vapor Store, so we can do these searches very quickly. For example, if you were narrowing down to a field here, you wouldn't want to be making 11,000 API calls for every individual filter you're filtering down through to an external place. So that's one of the reasons why we use this file system in this way. In addition to the data browser, which is one way to bring data into your project, we also have a few different ways to bring in data from other data portals. So many of the groups that we work with have existing data portals, like the Kids First one we talked about earlier. And also within the CRDC, the model is that there's many different portals, each of which, or many different nodes, each of which have their own portal. So we've developed a couple different ways to bring data from those portals into the platform. And in the CRDC, we use a manifest that contains the GUIDs and the file names to understand which file is important. But for all of these, to have this be an experience that's easy for the user and quick for the user, we have to kind of pre-index the data, have all that file information and metadata already present in the Vapor Store to get all of those nice advantages of being able to look through data quickly, use the metadata for batching, and so on. To give you a sense of what this looks like on the back end, here's another sort of representation of the file system. So how this works for data where it's located in, say, a node behind fence is shown here. So we do authentication and authorization. That information is also held within the Vapor Store through something that we call tags. So whenever a user logs into the system, we get information about what basically the PHS numbers of the dbGaP studies they have access to. And we assign a tag for each of those data sets. And every file has a tag, and every user has a list of tags that they have access to. And when they log in, that information is basically recorded in the platform in the file system. When they're doing something like, let's say, searching through data browser, we're able to check and make sure those tags match. And if they match, they can copy that data into their project. If they don't match, they can't copy the data into the project and we'll get an error message. When they go to actually run the file in a workflow, the location of the file is actually a GUID from Fence. So we get that information from Fence. And at the time of running, we also see the tag on that file and can match it up with the tag of the user. And if they match, the user gets back a signed URL and can run the workflow. And if they don't match, they don't get back a signed URL. So this is the two-step authorization and authentication process that we go through. And for this to work, basically every data set needs to be indexed through Fence. And we rely on Fence for the information we use to tag both the users and the files in our system. So that's a bunch of information about bringing in data and the services that underlie how we manage all the files and the metadata in our platform. I'll end quickly just by touching on how workflows are run in our platform. The CGC uses common workflow language, or all of the Seven Bridges platform use common workflow language. This is a community-driven language that we heard a lot about in the Dockstore presentation as well. And Seven Bridges is one of the communities, one of the members of that community. It's a very large community. It's not just bioinformatics. It's many, many different fields. And it's a totally open source. So it's a very wide community, and it's very, very well documented. There's a lot of resources for it. In terms of using CWL, there's a bunch of different ways to do this as well. So you can basically write it by hand, raw code. You can use our Rabix composer as a graphical editor to basically write CWL without being an expert in the syntax of CWL. And there are other tools out there as well. So if you're more comfortable in R and Python, there are ways to compose CWL in R and Python as well. And CWL obviously focuses on portability. The sort of conformance and modular aspects of CWL kind of forces the people who use CWL to consider all of these portability aspects when they're writing. There's a lot of kind of checks and balances built in. CWL isn't working in a vacuum. Kind of all together is how we can make it really easy to run workflows on the platform. As I mentioned, we have Rabix Composer, which is our graphical way of of wrapping tools in CWL. So again, the really nice aspect here is that you don't have to learn and be an expert to use a tool wrapped in CWL. You can use this graphical interface and it basically does the CWL part for you, which can make things a lot simpler and reduce errors. You don't have to do everything yourself. It just basically simplifies the generation of CWL and speeds up the process. And then once you have your tool wrapped, you can execute it with all of our platforms use Rapix Executor as the executor of the CWL, but there are a number of other executors out there as well. So that's how we kind of the little bit more detailed version of how we run workflows on the platform. And we will get into actually using all of this a little bit more tomorrow when we do the demo. So that is the intro to the platforms. And if there's time, I'm happy to take questions, or we can take it offline as well.
Thank you, Manisha. We're running a little behind, so I'd ask folks to hold questions, and also ask Manisha maybe schedule one of the Q&A virtual sessions for this evening or tomorrow.